Everyone, so today we are going to discuss very interesting problem, which is find the closest node to the given two nodes. So let's first read the problem description and then we will understand what the problem statement is saying and how we can solve this. So the problem statement is you are given a directed graph of n nodes number from 0 to n minus 1 where each node has at most one outgoing edge. The graph is represented with zero index array edges of size n, including that there is a directed edge from I to node edges of I. If there is no outgoing edge from I, then edges of I is equals to minus 1. You are also given two nodes, node 1 and node 2. Return the indexes of node that can be reached from both node 1 and node 2 such that the maximum distance between node 1 and node such that maximum between the distance from node 1 to the node and from node 2 to the node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer, then return minus 1. Note that it just may contain cycles. So let me explain you as the problem description is a little bit hard. So let me explain you the problem statement. It is saying that we have given this edges array, and by this edges array we have to form a graph, and we are given these two nodes. So we have to tell them that which is the closest distance node which can be reached from both these two nodes. So in this case, from this first node given as 0 and this second node as 1, so which is the closest node which can be used from both of them in the minimum distances 2. So that 2 become our answer. So let first we will discuss how this graph is formed. So as this is the directed graph and the formation of graph is saying that uh, let me explain your thought. Now let me use this paint. So this is given at zeroth index, this is as 1, this is as 2th, and this is a third index. So this is saying that from index to the value there is a edge. So from 0 to 2 there is a edge, from 1 to 2 there is a edge, and from 3 to 2 there is a edge. And if not there is not any edge from any node, then whose value is minus 1. So from at the third index there is no outgoing is, so this value is minus 1 as we have given. So let me explain you throughout a big example so that you can understand better what the problem statement is saying. So I have taken a bigger example for you. So let me explain you throughout it. So here is a long test case, and this graph will be formed when we draw the graph. So basically, as I have explained, this is 0 1 2 3. So from 0 to 4 there is a edge, from 1 to 4 there is edge, from 2 to 1 there is a edge, and doing all of this graph will be formed. So what we have to tell the minimum distance node which we can reach from these and these two nodes. So that this node is 2 and this 9. So which node we can reach first? So the distance from 2 to 1 is 1, 2 to 4 is 2, 2 to from 2 to 0 we cannot reach because from there to here there is noise. So from 2 to 13 is 3, 4, 5, so on. And from 9, what are the distances of the node which it can reach? Basically for 2 there is one more is left, this is 6. And for 9, what are the distances of reaching the nodes? So for this node it can reach in one time, this can reach in two time, as there are directed edges between them. Here it is in three time. So as we can see, like from here to here, and this 9 cannot reach, like it can reach 4, 5, and 6 time. So what it is saying, like we have to return the minimum distance node from both of them. So as we can see, this node. So what is the maximum distance? In which both are the node are reachable to this fourth number node is 3. So the three time for this three, and for this the 9 is reaching in 4 minutes and this 2 is reaching in 3 minutes. So what is the maximum time for this? Is 4. Here the 2 is reaching in 4 minutes and this 5 is reaching in 5 minutes. So the maximum answer is 4. Here the maximum answer is 5. So what is the minimum answer we get? We get the minimum answer is 3. So what we can do, we can return 4 as an answer, as we can reach in minimum 3 minutes from both of the nodes. So this 4 will be our answer. So now the question is how we can solve this problem. So we can just use a simple DFS, and as we dry run here, what basically we see in context of code, what we are doing, we are just simply making a DFS and storing the distance of reaching the current node in somewhere in a array kind of data structure, and then just we are comparing which node give us a minimum distance, and that node will become our answer. So let's move to the code and then I will explain you, I think, better. So here I have pre-written the code so that I explain you. So what I have did, I have made two arrays and initialized them initially with -1 so that I can determine that the node is reachable from this node or a node. Suppose what we are doing, like if we make a call from 3, then and we have a previous array which is initialized with -1. So we will not go, if we will not reach to the ith node, then this value will always be -1. So we can determine by this. So that's why we are initializing them with -1. And then what we are doing a DFS on both the arrays with each node containing the first node and the first array, and the second node the second array, and the initial time is 0 for both of them. So let's see what the DFS function is doing. So this DFS function is basically doing, we are like going from the node to node and updating the time, and then storing that time to these distance arrays so that we can afterwards calculate our answer. So what we are doing, we suppose we are from, like, we have this array as -1 -1 -1. So what we are doing, if we are going from here to what we are doing, we are storing this by current distance 0 here, and then go to here, and here we will reach to the 2, and this distance will be 1. So we are storing these indices, and also this distance array will help us to do not visit to the visited nodes, as the problem statement says that it may contain cycle. So this, there may be a case that uh, uh, we go from there 3 to this node and from here to here, so we will keep moving in this cycle. So this distance node will prevent us from this, as if we update uh, any node, like if we reach here from any node, then we will mark this node as a time. So next time this value will not be equal to -1, right? So we are moving here if this value is equal to the -1. Like if this current node is not visible, then only we are moving. If this node is visited in any previous cell, then we are not moving here. So so this will make our both two arrays for us, and then what we will do, then we just simply compare both of them. If both what we are doing, like we have make a index as -1 so that we can return the answer, and this temporary value, like we are doing it for storing the minimum time minimum time to reach from both of the nodes. So what we have did here, first we check if this ith node is reachable from is reachable from the like source node or a node. So if it is reachable, this obviously its value is not equal to the -1. So if those both ith node value is not equal to the -1, then this means that these both nodes are reachable from the source, their source nodes. Basically these are the source nodes, and then we will explain the distance uh, uh, what we are comparing, the distance reachable from both node max of them and our previous value. So our previous value is the maximum one. So what we will do, we will just store the maximum value from both of them in the temporary variable, and the indexes value of both of them to the index variable. And then what we'll do next, this iteration will go. So here the max value was stored in this, and if we found any of the lesser value from this, then we will store that value in this temp variable, and this indexes I will become our next answer. So let me explain our the time complexity. So what will be our time complexity? So time complexity will be like we are only traversing each node only one time, as we are maintaining this visited array as distance array. So for both two sources, we will take O of n, and O of n. So basically n plus n. This is in Vigo of time complexity. This is considered as Vigo of n, and we are taking complexity space complexity and of O of n and O of n. So this will become again same. So this was the solution. Thank you for watching my video.